Okay, 2.3. This is about exponent rules, and for some reason, this book actually put volumes and areas and perimeters along with exponent rules. I know there's a connection there, but it's kind of strange that they would put these two together being taught at the same time. Anyway, we'll make a go of it and see what happens. All right, let's look at let's not use this Explorer because we have to deal with some formulas first before we do this, and I don't know if it's worth it. So I want to take a look though at the formulas. Okay, for a rectangle, we know that the area, most of us know that it's length times width. Parallelogram, base times the height. Triangle, 1/2 base times height. Trapezoid is the area is 1/2 times the height times big B plus little b. Now, I'm going to use, now they're using the capital B and the little b to distinguish the different bases. Okay. We're going to follow like we did with the and back in geometry in algebra 2, we're going to use instead of capital B, we're going to distinguish between the two different bases, we're going to call them B1 and B2. Little b1 and little b2. B sub 1, B sub 2. Okay. Next page. Circle, the diameter is 2 times radius. Area equals pi r squared. The circumference is 2 times pi times radius, or since 2 times r is the diameter, you could just take pi times diameter. Cylinder, volume of the cylinder is pi r squared times the height. The volume for a sphere is 2 pi r squared. I'm sorry, that's the surface area. Volume, surface area, 2 pi r squared plus 2 pi r h. So we have volume and surface area. Cone, volume 1/3 times pi r squared times the height. Here's the sphere. Sphere's volume is 4/3 times pi times r cubed. The surface area is 4 times pi times r squared. And then a rectangular prism or cube. Cube's a little different. It's a special rectangular prism. The volume's length times width times height. Now, here's the representations of all this. Capital A is area. Capital V is volume. Capital S is surface area. Capital B, again, they use it. Capital B is used for, if you remember your geometry in the tetrahedrons or the solid prisms, capital B represented the area of the base of the prism. So we're going to keep it that way. I don't know if this section gets into it, but if you do run into it, that's what it really is. It's the area of the base of the prism. Little l, length. Little w, width. Little b is base. R radius. Little d, diameter. And h represents the height. Little h is height. Okay. It says formulas for all of these specific dimensions, that perimeter, area, volume, surface area. It's common to use only numbers in the formulas, okay, without units, and then state the units with the answer. In other words, be careful of the labels. A lot of the labels, and this is probably why they tied in exponent rules with all of the geometric areas and surface area, is because all of the units that you use are exponential or exponents, like volumes cubes, areas squared, perimeters linear to the first power. Okay, now we're going to get into some old exponent rules. Should be all review for everybody. 5 to the third. Now power, of course, is made up of a base raised to an exponent. Let me use, you know what? Let me just use base raised to an exponent. This whole thing is called power. It's definition of a power. Okay, so when I have two bases being multiplied together, I add the exponents, 3 plus 4, to get 5 to the 7th. If I have parentheses, now this is kind of, it's called the power to a power, but always do follow your PEMDAS. Always do the mathematical operation inside parentheses if you can. So inside the parentheses, I got 3 times 5 or 15, and then square it. Okay, so that would be 15 times 15, 15 squared is 225. Okay, so here, always follow PEMDAS. Parentheses first. Parentheses, exponents, multiplication, division, adding, and subtraction. Okay, then we have a division with different bases raised to a power. Don't forget, if there's not a power shown, it's the power 1. Okay, what we do in this case is we distribute that 2 to each of the exponents, because there's parentheses. Whenever you see parentheses, think of distribution. So we get 2 to the 1 times 2, or 2, over 3 to the 1 times 2, 3 over 2. Multiply it out. 2 squared is 4. 3 squared is 9. It's simplified. Conjecture is distribute the exponent. Okay, I think my dog's done barking. Okay, D says I have a power, 7 to the third, raised to another power. Again, the rule of thumb here is to, whenever you see parentheses, exponent outside the parentheses, distribute it. Oh, it's to the third, squared. So we want to distribute it. So I get 7 to the 6th Notice we're multiplying because of the parentheses, we're not adding. 6, which I don't know, I don't have a calculator, so it's going to be, I guess I go use my phone. Seven, and of course it doesn't have a erase button. Times 7 times 7 times 7, and I get 823,543. Again, you distribute and multiply the exponents. Distribute, multiply exponents. When I have division with the same base, we're going to subtract the exponents. 5 minus 2 equals 11 cubed, 11 cubed, 11 times 11 times 11, 1,331. So subtract exponents. Okay, now next, all this stuff they got here is they're trying to show you a pattern. What they're ultimately getting to is that anything raised to the 0 power is 1. Okay, exponents. Again, this is what we just went all through. If I have a power with the same base, add the exponents. If I have division with the same base, subtract exponents. Anything raised to the 0 power is 1. This is a power to a power. You multiply, remember you have a power exponent outside that parenthesis, you multiply. If there's not a power there, remember there's always a 1 there, so that when you distribute to each exponent. So x to the exponent, 1 times a is x to the a, y to the 1 times a is y to the a. Different bases in a division problem, you have to remember each has its own exponent. You have to distribute that exponent outside to each of the exponents because they're different bases. So I have x to the a divided by x to the 1 times a is a. Okay. There is an exception. Anything, remember I told you anything raised to the 0 power is 1. However, 0 to the 0 power is 0. Anything else is going to be 1. X to the third. X to the third raised to the 0 power is 1. Okay? Okay, number 4. So we're going to do some simplification. Sometimes it's easier to regroup these into x's, y's, and numbers. Here I have all multiplication. My numbers, I have 17 times 2. My x's, I have x squared times x to the 5th. You don't have to regroup them. I think it's just easier to do. 17 times 2, see 14, 34, x, they're being multiplied, so we add the exponents. Now, be careful with negative numbers. We're taking, remember there's a 1 there, so we have to distribute. that 2 to each exponent. This is a negative 5. So it actually is negative 5 squared. X to the 3 times 2 is 6. In your calculators, if you don't put parentheses around negative numbers, you're going to get the wrong answer. In other words, if you put in your calculator negative 5 squared, you're going to get negative 25, and that's the wrong answer. That's because of PEMDAS. Parentheses first. Okay, so I have negative 5 squared is 25, x to the 6th. Anything raised to the 0 power, 1. Okay. Now we're going to have a little bit of a tricky problem here. Don't forget the 3 has an exponent of 1, the x has an exponent of 1, the y has an exponent of 2, this 3 has an exponent of 1, that y has an exponent of 3. Distribute each exponent. So I have 3 to the 1 times 2 is 3 to the 2. X to the 1 times 2 is x squared. Y to the 2 times 2 is y to the 4th. 3, so I'm distributing to each exponent. So 3 to the 1 times 2 is 3 to the 2. Y to the 3 times 2 is y to the 6. So this is 3 squared is 9, 3 squared is 9. These ultimately are going to cancel out. I have an x squared left. Y to the 4 minus 6. So I'm going to do that off to the side here. Y to the 4 minus 6 equals y to the negative 2. And if you remember back from algebra 2 and even algebra 1, you can never have a negative exponent. To get rid of negative exponents, you flip it. So y to the negative 2 is over 1. You flip it and make that exponent positive. So that y to the 2 goes in the bottom of our fraction. And there's my answer. Okay, 4 has an exponent of 1. Distribute. 2 times 1, 2 times 4. I get 4. 1 times 2 is 2. X to the 4 times 2 is 8. 4 squared is 16x to the 8th. Anything raised to the 0 power is 1. Okay, exponents. 3 to the 1st, 6 to the 1st. Distribute the exponent to every exponent that's there. So I get 3 to the 1 times 2 is 2. X to the 4 times 2 is 8. 6 to the 1 times 2 is 6 squared. And x to the 3 times 2 is x to the 6. Okay, 3 squared is 9. 6 squared is 36. 936 can be reduced to 1/4. X to the 8 minus 6 is x squared. It's positive, so it's going to stay up on top. Okay, H. I have 8. Oh, we have a 2 outside here, parentheses. So I'm going to need to distribute 4 to the 1st, y squared, z to the 1st. need to distribute. Let's see, 2 times, so I have my 8, my x to the first, y to the first, z times, now after I'm done distributing, use this all multiplication. After I'm done distributing, I can drop the parentheses. So I have 4 to the 1 times 2 is 4 squared. X to the 2 times 2 is x to the 4th. Y to the 2 times 2 is y to the 4th. And z to the 1 times 2 is z to the 2. Now you can either put all these in order, or you can probably do a lot of this in your head. Don't forget, there's no exponent there, it's a 1. Okay, 8 times, this is 16, 8 times 16 equals, let's see, 48, carry the 4. So 1 times 8 is 8 plus 4 is 128. X to the 1 plus 4 is x to the 5th. Y to the 1 plus 4 is 5th. And then z to the 1 plus 2 is 3. There's my answer. So these can get lengthy and tricky, just like you learned in Algebra 2. They can get a little tricky. The more complicated they are, the harder they are. You got to follow your rules. Okay, volumes, perimeters, and surface areas now. It says find the volume of a cylinder with a radius of 4 centimeters and a height of 8 centimeters. Include units in your work. In other words, include the labels. Always start out with the formula you're going to use. Okay. Find the area of a triangle whose base is 5 inches and whose base is 5, height is, so area of a triangle. It's 1/2 the base times the height. Here's what they give us. Base is 5 and the height is 20. So all we have to do is plug it in our formula. Area equals 1/2 the base times the height. This one's actually a lot easier than you think. 5 times 20 is 100. Half of 100 is 50. Don't forget the units. Inches squared. Area squared. Find the volume of a cylinder. So I'm going to go back and look at my volume of a cylinder. I'm going to go back to the sheet. Volume of a cylinder equals pi r squared times h. Let's see what they give us. Radius is 2. Height is 1. And use 3.14 for pi. So volume is going to equal 3.14 for pi times the radius, 2 squared, times the height, which is 1. Put that all in our calculator. Okay, I get 12.56. My label, centimeters, volume is cubed. C. Sphere, find the surface area. So surface area for a sphere, go back to my formula sheet. Sphere is 4 pi r squared. 4 pi r squared. And they give us in the problem, find the ratio of its volume to its surface area. So this volume is 4/3 pi r cubed. And we're supposed to find the ratio to its volume. So the volume is on top, 4/3 pi r cubed. Ratio is a fraction, 4 pi r squared. Okay, 4/3 divided by 4. Let me do that in my calculator. 4/3 divided by 4 gives me 1/3. 1/3. My pi's are going to cancel. R to the 3 minus 2, because the exponent rule, same base, subtract the exponent. R to the first, so that stays in top. If I want to just clean it up, make it R over 3. That's the ratio. Okay. 6 says find the area of a square whose side has length 3. Now, a square is that special formula because all sides are equal. The area of a square is just side squared. And here they give us the side equals 3 centimeters. So this equals 3 squared, or 9 centimeters squared. B, find the volume of a cube whose sides have lengths of 5 feet. Now, volume of a rectangular prism is length times width times height, and we know that a cube is going to be all the length equals the width, which equals the height, so it's just going to be the side cubed. Area equals side cubed. In this case, it's 5 cubed. 5 times 5 is 25, times 5 is 125 feet cubed. Volume is cubed. Okay. Fractional exponents is, again, back in Algebra 2, you learn that exponent form and then there's radical form. And you should have learned that these, just like addition and subtraction, multiplication, division, the radical form undoes the exponent form. So these undo each other. And the way that we did that was if I have a base to the exponent in exponent form, in exponent form, it's the base to the exponent over the root. And in radical form, now these go back and forth, it's the root to the base of the exponent underneath the radical. So that's how we're going to go back and forth from exponent form to radical form. In other words, if I have 64 to the 1/3, which is in exponent form, they want us to do it in radical form. Well, my base here, 64, my exponent is the numerator of the fraction. So the exponent is 1. And then my root for this problem, I'm going to use a different color. The root is going to equal the denominator of the fraction in exponent form. So it's 3. So to change that to radical form, well, I got to have my radical. My root is 3, goes in here. My base, 64. And then my exponent was 1. So 64 to the 1/3 is actually the cube root of 64 to the 1st. If I have a negative sign, it's the same thing, just keep the parentheses around the negative number. So here's my radical, still cube root. This time it's negative 64 to the 1st power. 16, again, my base, to change it to radical form, I need my radical. My base, 16. My numerator is the exponent of the base. The denominator is the root of the radical. My base, here's the radical. My base is 144. My numerator is the exponent of the base, and my radical is squared. By the way, if this is if the root is 2, we normally don't put the 2 there. We just say square root of 144. And that's it. So you should be able to do your homework from here. Let's see if there's anything. Square feet, volume, formula, guess it's for a full cycle of spin. We should be able to do this. This is a little tricky, but give it a try. All this other stuff you should be able to do. And that's it for 2.3.